Tsubo Lab is a startup venture company from Keio University School of Medicine. Established in 1920, the Keio University School of Medicine was the first private medical school in Japan. The value of a university stems from its ability to generate new ideas and contribute to society through scholarship. Our CEO, Dr. Kazuo Tsubota, is the sixth professor of the Department of Ophthalmology and is known as one of the most prolific among researchers and clinicians in ophthalmology. Innovation is said to be a marriage of science and commercialization. Viewed within that framework, one could say that Tsubo Lab is a university startup, blending medical school intellectual property with business school management. Our company's mission is, through innovation in health and medical fields, we will make the world happier and healthier. Let's introduce our research and development activities. Our research and development focuses on three major diseases in ophthalmology: dry eye, myopia, and presbyopia. Based on the knowledge of CEO Professor Kazuo Tsubota, we are working on the development of innovative treatments, prevention, and medical devices on dry eyes. To stop the global increase of myopia, we are conducting research and development based on our novel violet light theory. Our dream is to protect children from myopia through our new myopia prevention method and clinical application. Presbyopia can be considered as a sign of aging, not only in eyes but the entire body. We are developing an antioxidant supplement for prevention, as well as measurement techniques for stiffness of the crystalline lens. These are the three major fields Tsubo Lab is focusing on. In this video, we will introduce the cutting-edge science of myopia. Myopia persists as one of the biggest challenges in ophthalmology. It is spiraling globally, with some 2.5 billion sufferers at present, a figure expected to double by 2050. Myopia is not merely a problem which can be solved by eyeglasses. It is a severe threat which can lead to loss of eyesight, and therefore urgent intervention is necessary. This is a research field of unmet needs, estimated to represent 9 trillion yen in Asia and 3 trillion yen in the West. What is myopia? Myopia is a condition in which you can see objects near to you clearly, but objects at a distance are out of focus and blurred. It often develops during childhood and progresses with growth. Myopia occurs when the eye grows too long from front to back, causing light to come to a focus in front of the retina instead of directly on it. If left untreated, high myopia is one of the leading causes of visual impairment worldwide. The greater the degree of myopia, the greater the risk of complications such as macular degeneration, retinal detachment, cataracts, and glaucoma. The cause of myopia remains unknown. There is ongoing discussion whether it is due to genetic or environmental factors, and here are some data for the potential answer. Parental history of myopia was said to be an important predictor, but please look at this chart. Lower amounts of outdoor activity increase the odds of becoming myopic in children whose parents are both myopic, more than in children with neither or one myopic parent. The lowest odds ratios for myopia were found in groups reporting the highest levels of outdoor activity. Here is further data comparing children aged 6 to 7 years old living in Singapore, where there is less outdoor activity, and Australia, where there is much more. In Singapore, they play outside 25 minutes a day and almost 30% have myopia. But in Australia, they are outside 2 hours a day and only 3.1% have myopia. What is the secret of outdoor activity? Our team found the cause in sunlight. Most organisms use sunlight to survive. For example, plants like sunflowers move in the direction of the sun. They have a sensor for the sun even though they don't have eyes. When we began our study, we focused on the relationship between photobiology and genes. the cycle of life that has been around for 2.5 billion years. While the mechanism of myopia onset and progression remains unknown, we can point to our epoch-making research findings on the suppressive effects of violet light, which has a wavelength of 360 to 400 nanometers for myopia progression, and we have shown the effects of suppressing the progression of myopia with violet light on mice and chick myopia animal models. And we have further indicated the role of transcription factor EGR1 as the molecular mechanism for the suppressive effects on myopia progression. Now, we have partnered with Genes Incorporated, a Japanese eyewear company, in a clinical research study and clinical trials of violet light transmitting lenses and violet light emitting eyeglass frames as a further initiative in myopia progression prevention. As of 2020, we have obtained 12 patents related to myopia prevention. These developments have been accomplished based on science. Following are some of our published papers related to myopia prevention. Again, the fusion of science and commercialization is innovation. Tsubo Lab is leading innovation to decrease the myopic population based on the science of the violet light theory through commercialization and collaboration with partner companies. We are always open to working with future partners that are interested in realizing this innovation together.